Hey everybody, it's Zoe. Today I'm going to be talking about reaction rates in Chapter 13. Let's start by going over some definitions. The rate of a reaction is a measure of increase of concentration or partial pressures of products or a measure of decrease of concentration or partial pressures of reactants as a function of time. The rate of formation is the rate at which products are formed, and the rate of consumption is the rate at which reactants are consumed. Some things that affect reaction rates are the physical state of reactants, reactants concentrations, the reaction temperature, and a catalyst. When I solve simple rate problems, I look at the chemical reaction and I subtract the final concentration by the initial concentration and divide by the change in time. This first example is dealing with a product, let's call it C. We're going to take the final concentration of C and subtract it by the initial concentration of C and divide it by the final time subtracted by the initial time. The shorthand of writing these problems is taking the change in concentration of C and dividing it by the change in time. The change is represented by the triangle. Working with another example, I wrote out a little fake chemical equation. In this problem, we're going to be finding the rate of consumption, so we're dealing with reactants. So if you were asked to find the rate of consumption for A, you would put a negative sign in front of the whole equation, take the final concentration of A, subtract it by the initial concentration of A, and divide by the final time minus the initial time. Again, at the bottom, I wrote the shorthand of this equation. If you're wondering why the negative sign is there, it's because it allows the final values to be positive because the final concentration is always less than the initial concentration. If you were asked to find the average rates of consumption and formation, you would do the same processes as shown previously. The only difference is adding the coefficients in the denominator of the corresponding fraction. The rates will generally always come out as positive values. I again created a fake chemical equation to show you the relationship between rates. You already know how to find three types of rates, it's just a matter of figuring out how they correspond. So with the rate of reaction, you're just setting the rate of formation and the rate of consumption equal to each other. And finding the rate of formation, the rate of C is equal to the change in concentration of C over the change in time, as well as negative C over A times the change in concentration of A divided by the change in time. Just for clarification, the lowercase c and A are coefficients. With the rate of consumption, the rate of A is equal to the negative change in concentration of A divided by the change in concentration of T, as well as it's equal to A over C times the change in concentration of C divided by the change in time. So once you kind of get familiar with these relationships, you can plug in the things you know to figure out the things you don't know in these equations. That's all for today in this concept video. I hope you enjoyed. Thanks for watching.